Welcome back to our next video. We are now looking at conglomerates of these weird rational exponents. So remember, these rational exponents are just a fancy way of writing different kind of roots, like square roots and cube roots. But they are also numbers, fraction numbers. So all of our exponent rules apply to these. The fact that they're fractions doesn't change anything for our exponent rules. So in A here, we have our side by side, x to the 3/4, x to the 7/4, and then all of that is over x to the 1/4. So the side by side next door neighbors, those are going to add. Upstairs, downstairs, those powers are going to subtract. So I'm going to do it one step at a time. So the top becomes x to the 3/4 plus 7/4. All of that is the power. Writing that can be awkward, typing it is even worse. But hopefully you're seeing what I'm saying, where all of that is a power now. And then we still have that x to the 1/4. Now the nice thing is here, they're all fourths, so they already have a common denominator, so we can add them. You could also just use the calculator by all means. So 3/4 plus 7/4 is 10/4, which does reduce, but since the bottom one is already in fourths, I'm not going to bother reducing that. Since I need to combine the bottom one with it, this way the fourths common denominators stay. So upstairs, downstairs don't get along, negative relationship. We subtract the powers, top minus bottom. So 10/4 minus 1/4 is 9/4. All right. So that should be the answer you need for this type of problem. There is the possibility it wants it in radical notation. Later on, we're going to talk about how to simplify radical notations. But for here, I'm just going to write it's the fourth root, because that's the bottom number. We say 9/4, so fourth root of x to the 9th. So there's some groupings of the x's that could come out of this. But for right now, we're just going to leave it like that. And like I said, I'm pretty sure that is the answer Alex will want. But if I'm wrong, please let me know. All right, now this craziness, I got powers outside, upstairs, downstairs, multiplying fraction, like all sorts of nonsense. But we can do this, and it's a good review for the test. Hint, hint, nudge, nudge, wink, wink. In other words, yes, you will have an exponent rules problem. But it's on the review, so this is not a surprise. All righty. So since inside each fraction there are no like terms, but between the fractions there are, but I can't interact those until I get rid of those exponents. So I need to deal with the cube and the squared. So everybody in the first one is going to get cubed. So we have now 4 cubed. A to the 2/3 cubed. B to the 1/6 cubed times, and now everybody gets a squared. E to the 1/4 squared. 3 squared. A to the 3/4 squared. Now, if that 4 or that 3 was negative, then I would also write that in parentheses. And if you want to write the 3 and 4 in parentheses, you can. I am not doing so because I will run out of room and my handwriting on this screen is not as good as I would like yet. All right. So now that we have done that, I need to interact these crazy things. So the 4 to the 3rd, I can calculate out. 4 times 4 is 16. 4 16s is 64. I just know that because after a while writing these problems, you memorize all these lower powers. All right, so that's a 64. Now a to the 2/3 to the 3. So remember, this is power to a power, Just like we were seeing earlier, quantum of mathematics, so they multiply. And the nice thing here is 2/3 times 3. 3's are going to cancel, and that is just 2. So a squared. On the bottom, we get some nice interaction. B to the 1/6 to the third, 1/6 times 3 would be 3/6, which reduces to 1/2. So the bottom is now B to the 1/2. Now our other fraction, 1/4 to the second. 1/4 times 2 is 2/4 or 1/2. Hey, look. B to the 1/2 on the top and bottom. Woohoo! It would help if I write 1/2. So those are going to cancel in our next step. But for now, we're just one thing at a time. We're just cleaning up all these to this. So 3 squared is the number 9. And since 4 and 3 didn't have anything reducible, their higher powers won't either. 64 is a bunch of 4s, 9 is a bunch of 3s. You're just going to have 64/9 in your final answer. So a to the 3/4 squared. So 3 times 2 is 6/4. But that does reduce. 6/4, they're both divided by 2, so that'd be 3/2. So we have an a to the 3/2 here. All right, now we just gotta clean this up a little. So, like I said, we're gonna have the 64 and the 9. And then our b's, because they are exactly the same, they cancel each other out, or upstairs downstairs rule. B to the 1/2 minus 1/2 would be 0. Anything to the 0 power is 1. Multiplying by 1, we don't have to write it. So I just emphasize that because I don't want you to think they turned into zeros, because then you might think, oh, there's a 0 on the bottom. They cancel divide because they're the same to a 1. Now we just have to figure out those a's. So I have a squared on top, a to the 3/2 on the bottom. Upstairs, downstairs, we're going to subtract 2 minus 3/2. Well, 2 is the same as 4/2. 4/2 minus 3/2, 1/2. So a to the 1/2, which we could also write as the square root of a. And we could write it with the square root of a off to the side and 64/9 just as a coefficient number, or we could put the square root of a on top of the fraction. Alex should take any one of those answers. It might have a preference for the root, but I'm pretty sure it'll actually prefer the a to the 1/2 more. That's certainly the more useful form if you're going to go into calculus. But by the time you get to calculus, you will totally forget all of this, and they have to remind you, and then you're like, oh yeah, I vaguely remember that. Multiply. All right. I say this because I often have to remind calculus students back when I tutored more. All right, now we got this ugly mess. -125 to the -2/3. Now the nice thing is, you can crunch that on the calculator. It is a fraction, so you also need a calculator that'll convert it back to a fraction because the decimal answer won't go well. But that works. The only thing you might have to watch out for is, especially a negative fractional power, the calculator doesn't always like that, so you might have to do it a step at a time. I personally prefer to do the fractional part first because these numbers are often designed to interact well with the root, with the, in this case, cube root. So that is what I'm going to start with, is I'm going to translate this. So we have -125. And then I'm going to raise this to the 1/3. And I'm going to leave the -2 power. So this is a power to a power, a little bit harder condom in between them, but still, same thing. -2 times 1/3 would be -2/3. So all of our exponent rules, if it's an equality, it goes both ways. You can use it forwards, you can use it backwards. Here I'm using it backwards, which is weird. I'm complicating my problem, but it's so I can simplify it in a easier way. So -125, hopefully 125 sounds familiar as 5/4. So 5 25s, and 25 is indeed 5 times 5. In fact, we just did this in the previous video. Since it is -125, if all of these 5s were negative, negative times negative would be back to positive 25. Positive 25 times negative 5 would be negative 125. So negative 125 is the same as negative 5 cubed. All right, so we'll leave that negative 2 there. And then inside, so many parentheses, negative 5 cubed to the 1/3. It's the 3 and the 1/3. 3 times 1/3 is 1. We don't have to write 1 as a power. So whew, this is now with the brackets, negative 5 to the negative 2 power. Now, don't actually type brackets on your calculator. If you have that option, it usually means something else. The only reason we use brackets through here is so we're not writing curved parentheses like 4 times, because it's really hard to count how many then. So we'll alternate with brackets so it's easier to see. But for here in math where y'all are, the brackets mean the same as parentheses. Just type parentheses on your calculator. So we have negative 5 to the negative 2 power. Now this negative 5 and negative 2, this is not multiplication, this is a power. So we need to interpret what that negative means in the exponent. So that is our floor change. Person does not like the dorm room they're in. They're not on the, we don't see upstairs, downstairs, so we dig them a basement. That is our next visual. So I dig them the basement, and I'm going to switch to the parentheses now. So it's negative 5. And now my exponent's happy in the basement. It's positive 2 now. So I have negative 5 in parentheses still, squared. If you don't have the parentheses and type that on the calculator, you will get a different answer. Or if you didn't have them and you put the parentheses in, you would get a different answer. You have to be careful with these negative numbers. So that's why I'm very carefully putting all those parentheses through the whole problem. But now negative 5 itself squared, negative times negative is positive. So our final answer is the lovely fraction 1/25. Again, if you type that into the calculator, poof, 1/25. I take that. That is work, right? Calculator. If you're unsure of your answer, you can write what you typed in the calculator. Because that way I can help you figure out a typo if there was one, if you have time to write it out. All right. Now, granted, just because I take work like this does not mean your college algebra professor will, but you're not going to have problems with all these icky exponent rules for them exactly the same way. All right. I'm going to stop it there.